Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to focus on the quadratic formula, keeping in mind that the quadratic function is still ax squared plus bx plus c. But today we're just going to take a roundabout look at the quadratic function by working with the quadratic formula, which is represented by x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this video, we are going to focus on the discriminant, in which we're going to take a look at three possibilities, right? And so the first possibility is this. If within the discriminant, or I should say under the square root sign, the same thing, b squared minus 4ac, if that quantity inside here is greater than 0, then we're going to have two real solutions. Well, if the discriminant shows b squared minus 4ac is equal to 0, then we're going to have one real solution. And then if the discriminant shows b squared minus 4ac, and that just happens to be less than 0, then there won't be real solutions. There are no real solutions. Well, what are solutions? Solutions are just simply roots or x-intercepts when the parabola crisscrosses the x-axis. And so we have two big examples to show you what's going to happen, what's going to take place here. And so let's take a look at our first big example in which we have x squared minus 6x plus 9. We're going to set it equal to 0. Keeping in mind that a is equal to 1 because that a is represented right here. B is equal to a negative 6, and C is equal to 9. And we're going to plug in those numbers into the quadratic formula to see what we get. And so when we do that, we have a minus negative 6 plus or minus the square root of negative 6 squared minus the combination of 4 times 1 times 9. All right, and so when we do that, let me mention this part, 2 times 1 all over 2 times 1, okay? So let me not forget that part. And so let's move on to the second step in which we have x is equal to now 6 plus or minus the square root of 36 minus 36. Now we know that what's going to happen here because we know that this is going to happen in the discriminant, which we're going to have it equal to 0, all divided by 2. And so now here's what we have. We have x is equal to 6 plus or minus the square root of 0, which is just 0. So now we have, and we're going to play it safe. Why don't we just write it like this? 6 plus 0 divided by 2 and 6 minus 0 divided by 2. It all comes out to 6 divided by 2, as you see right here, because it really doesn't make a difference. And so now that we have 6 divided by 2, which will give us 3 either way, that is our one real solution, simply because our discriminant is equivalent to 0. All right, so let's move on to our second big example in which we have x squared minus 3x plus 3. We're going to set it equal to 0, keeping in mind that a is equal to 1, b is equal to a negative 3, and c is equal to 3. Plugging everything into the quadratic formula, here's what we have. We have a minus negative 3 plus or minus the square root of negative 3 squared minus the combination of 4 times 1 times 3 all over 2 times 1. And when we work that out, we have x is equal to a 3 plus or minus the square root of 9 minus 12. And guess what? We have a situation in which the discriminant is less than 0. And we're going to see how that works out all over 2 because 2 times 1 is 2. And here's what we have in our third step. We have x is equal to 3 plus or minus the square root of negative 3 over 2. We're just going to leave it like that for now because that lets us know that we have no real solutions because the discriminant is less than 0. So I'll repeat, we have no real solutions because the discriminant is less than 0. We still have a parabola, but there won't be any points crisscrossing the x-axis. See, that's the key right there. All right, you have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at these two big examples or take a look at the three possibilities of the discriminant, or you can replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.